Hi, this is Tony Nichols from Great Ideas. The purpose of this video is to walk you through the WASM Components project provided by the TrellisSpark framework. This is the component that dynamically renders the pages in the TrellisSpark application. The root of this component is the pages instance. The purpose of the pages instance is to render the header, navigation, instance builder, and footer. Let's take a look at the underlying code. As you can see, the underlying code is very simple. All it's really attempting to do is to lay out a page. So we have a header component. Now, depending on whether we have collapsed the left navigation, we will display the instance builder, or we will lay out a table where we display the left-hand navigation and put the instance builder on the right. On this particular page implementation, we have not added a footer. All of our components, all of the dynamic page generation components get this cascading parameter called notification. The purpose of this parameter is to display the notification posts to keep track of the user's progress within the application. As the user navigates to this page, we check to see whether the user has been authenticated or not, and if the user has not been authenticated, then they're thrown back to the sign-in page for the website to ensure that they are authenticated before they can access any data. This is where the page is actually loading its data. So it's using the current instance service, and it's using the background form to load a new instance. We are attaching an event to the onChange event provided by the current user state service. So if the current user changes state, we're going to see whether or not they are still authenticated, and if not, navigate them back to the index page. Otherwise, we're going to refresh the user experience. So let's see how this looks in practice. So here we're looking at an example page from the user experience. At the top of the page, we can see the header. On the left of the page, we can see the navigation, and then everything from this grey bar downwards is part of the instance builder. Let's take a quick look at the structure of the header. The header is in the layout folder and contains three main regions: a logo, breadcrumbs, and the user manager information. Let's have a look at the underlying code. So here you can see the overall structure of the header information. It's breaking down into a single table with three columns. The first column is displaying the logo just by referencing an image source. The second column is displaying the breadcrumbs component. And the third column is displaying a Telerik menu which provides the drop-down controls for the user. Let's have a look at this in the application. So here we can see the logo, here are the breadcrumbs, and here is the user manager menu. If I click the My Profile, we see a modal pop-up comes up where we can change security questions and answers and the appearance. The My Profile pop-up window will vary depending upon the authentication mode of the website. This is using the standalone authentication model, so you can see that I can change my account, my security question and password, and also customize the appearance of the application. If I go to the Appearance tab, you can see I can toggle the tooltips on and off. So if I turn the tooltips off, you see that all of the text above the boxes has been removed. If I turn the tooltips back on, all of the descriptive text above and below the controls is returned. The user experience of this modal window is controlled by this Telerik window class. And as you can see, you have full control of which functions and features are available within the class. Now let's look at the structure of the breadcrumbs component. This component essentially has two elements. One is the ancestor links and the other is the status. Let's have a look at this in the application. So here are the breadcrumbs. You can see that I'm currently on the functionality for human resources, and that functionality is in the active state. Let's navigate into the human resources and have a look at how the breadcrumbs changes. So here we've gone to a list of form definitions within the functionality. If I select a random form, we can see that the human resources functionality is now a clickable link, that I'm currently on the background check, and that form is currently in the active state. Let's navigate further. I have now navigated to the human resources functionality, the form definition for background check, and I'm currently looking at the requested on field, which is still in the active state. I can go directly to any of the ancestor records by simply clicking the link. Let's have a quick look at the code. As you can see, the breadcrumbs are implemented using a Telerik tab strip control, which creates a new tab strip for every element in the instance's hierarchy. This code here is creating the set of tabs that will be displayed looking at the breadcrumbs of the currently selected instance. It determines the list of ancestors of the current instance by looking at the MyInstance parameters ancestors. When a user clicks an ancestor to navigate to, the first thing that happens is that we check that the current page is valid, so that all of the field validators in the instance builder are successful. Assuming that the page is valid, we next check to see whether or not there were any changes to any of the elements on the screen or on any previous tabs on this particular instance that the user has navigated to. If there were changes to be saved, then we attempt to save the instance. If the instance was not successfully saved, then we will display an error message. Once the error message has been saved, we check to see what the error was. So if we were trying to overwrite an existing version of the instance, we then give the user the option to decide whether they wish to reapply their changes to the latest version. This code is loading the current version of the instance. This code prompts the user with a dialog box to ask them whether they want to reapply the changes that they have just made. And if they decide they want to reapply the changes, then this code actually forces the changes to be reapplied to the current instance. If we're reapplying the changes that were cached, then we stop. If the user decides to reapply changes to the instance, then navigation stops at this point after the changes have been reapplied, and the user then has the option to save the page, make other changes, or do something else. On the other hand, if the form initially saves without error, we will display a success notification to the user. We will figure out which tab the user was navigating on. After we have displayed the success navigation, we will then load the selected instance from the breadcrumbs. Alternatively, if there were no changes to save on the original form, we will simply display a success notification saying that there are no changes to save, and then we will load the selected instance from the breadcrumbs. If the form failed validation, we will provide a dialog to the user asking them whether they want to navigate anyway. And if the user confirms they wish to navigate, then we will ignore any changes made to the form and go directly to the selected instance. Otherwise, we just prompt the user to fix the validation errors. The reason we've spent so long going through this code is that it is actually quite common as a process within the application. So within the Trellis Spark framework, this approach to navigation is common whether or not we're saving, navigating because we're moving to a different bookmark, or whether a user selects a different application page. So this code is common to multiple components. So we won't be describing it in detail as we go through the other components. So the next thing to look at is the layout navigation component. Structurally, this is a very simple component. It provides a set of applications, bookmarks, and queued commands. So let's have a quick look at the code. As you can see, this is a very simple component. We just have the applications and the bookmarks component being displayed here. And we have again the authentication check just to make sure that the user is signed in or it's navigated back to the root page. So let's have a quick look at the applications page. So this component is simply showing a Telerik menu where each of the items in the menu lists an application that the user has access to. The list of applications the user has access to is available from this XML here, which is being driven by the current user apps. The menu allows us to group specific applications into predefined application categories, as you can see in the example page. So this is an application that I can click to. This is an application category that contains a set of applications. Now let's have a look at the bookmarks. So the bookmark code looks a little bit more complex, but essentially it's doing the same sort of job. The key user experience is driven by this Telerik menu, which is only displayed if the current user has bookmarks defined. Again, the bookmarks are displayed as menu items, and they can be categorized. In this particular case, we also want to be able to edit and delete bookmarks, which is why we've added the button classes. So this is a bookmark category that can be edited, and here we have a command to delete bookmarks. As well as being able to see the current user's list of bookmarks, we also need to be able to bookmark a page. If the user has bookmarks, we also want to enable the user to be able to delete all bookmarks. When you bookmark a new instance, a pop-up window appears that also allows you to name the bookmark or categorize it. We also provide you the ability to edit an existing bookmark and a pop-up window to edit the bookmark category name. The list of bookmarks is held in the current user.user.bookmarks element, and this for loop is responsible for analyzing the bookmarks and producing the rendered list. If the user decides to go to the bookmark, then we're working through the same code that we saw earlier. We're checking the validation, we're going to save the instance, and so on. The main difference here is that the intent is to navigate to the selected bookmark, so that the only real difference that you'll see between the code that we looked at in the navigation for the breadcrumbs and the code that we're looking at here is that the navigation is going to the bookmark GUID instead of the ancestor GUID. The other functions in this component are interfacing with the backend database to provide and maintain the list of bookmarks. We do not recommend that you make any changes in this code area. Now let's consider the structure of the instance builder. The instance builder is responsible for laying out two components, primarily the command bar and the tab bar. Let's have a look at the example page. So the instance builder is rendering the command bar, which is the element in grey at the top, and then everything from here, which is the tab bar downwards, is displayed as part of the tab bar element. Let's start by looking at the command bar, as this is one of the most complicated elements in the system. The command bar has four distinct sections: the delete button, a drop-down list of commands, a drop-down list of generic functions, and then the save, undo, done buttons. The implementation of the command bar is controlled by this Telerik toolbar. So here we have the delete button. Here we're rendering a commands component. Here we're rendering the generic commands component. And here we have the final section of the save, undo, and done buttons. While processing a command, it may be necessary to gather other information from the user, and we have created a command bar modal window. So CB modal window is the user experience control that controls the layout of all of the pop-up windows that occur as you're using the commands. We have also created additional modal windows to deal with the case where we need to prompt the user for deletion or confirm that the user seriously wishes to delete a particular instance. This function is responsible for populating the generic commands available in this particular instance for this particular user. It controls things like whether the user can change the access or copy an instance, move an instance, online help, whether the user has the option of recovering instances or seeing previous versions of an instance, and seeing the milestones associated with the instance, or importing or exporting XML. Finally, this function toggles whether or not the save, undo, and delete buttons are visible. So this code is quite interesting because it's called every time the user changes the value of a field in the user experience. Essentially what this code is doing is it's checking to see whether or not the user has the ability to save changes at all, and then if the user can save changes, it's looking to determine whether or not there are any changes to save. If the user is allowed to save the form and there are changes to save, then the save and undo buttons are enabled. Otherwise, the save and undo buttons are disabled. If the user clicks on the delete button, so assuming that the delete button is enabled, if the user clicks on the delete button, then we toggle the deleted window visible and it displays either the delete prompt or the delete confirm pop-up window. If the user clicks on the save key, then we go through the same basic process that we saw on the breadcrumbs. The result here, however, is not navigation to a different component, it simply redisplays the latest version of the current instance selected. On the other hand, if the user clicks the undo button, then it loads the latest version of the instance back from the database, which would overwrite any changes that the user has made to the current form. If the user clicks on the done button, again we go through the same basic save process, but this time the net result is to go to the parent of the current instance. The CB modal windows component uses a Telerik window to provide a frame for a set of user experience components. So depending upon which button the user clicked in the command bar, either we're going to display a copy instance component, we can import or export an XML representation of the current object, we can move the current object to another parent, we can display all of the previous versions of the current object, we can display all of the milestones that have been achieved for the current instance, we can recover any child instances of this instances that have previously been deleted, and we can change the access control list of the current instance. So now let's have a look at the tab bar layout user control. Essentially what we're seeing here is that the tab bar contains a tab strip and then a set of row definitions. Let's have a look at that in our user experience. So this is the tab strip, and what we're seeing here is each of the tabs available on the current instance that can be seen by the current user. If there's only one tab available, the tab strips will be empty and we will just see the rows. The rows are always shown below the tab strip, and depending upon which tab is selected, we will see a different set of rows and a different set of data. Let's have a look at this in the code. So here you can see the user experience for the tab is essentially a Telerik tab strip. Here we're iterating through all of the tabs available and visible to the user, and then within the tab we're displaying a list of rows. And essentially this code here is determining which rows are visible for this user on the currently selected tab. Here we're using the row user experience component to render in sequence the specified row definition based on the current instance. This code is used whenever the user clicks on a new tab. Essentially what's happening here is that we are making a record of the new index and we are saving that in the instance state, and then we're forcing the tab to redisplay, which will essentially build a new set of rows. An interesting piece of code here is where we cache the old form tab. So if we navigate away from, say, the third tab on this instance as we navigate down into child objects, and then we want to navigate back to the parent, we will actually have a cached form tab that says that the last time we were looking at this particular instance, we were on tab 3. So instead of having to always display the first tab, we're actually caching the tab that we're currently on before we navigate away. So now let's look at the rows. As you can see, the rows are divided into a set of fields, and there can be different numbers and types of rows on each tab. So let's have a look at the row user experience and see how that's working. So by default, a row is going to lay out a set of fields on the page. As you can see from the diagram, each row contains a table that displays 7 elements. So this is what we describe as a generic row format. And we will have another video to show you how you can add your own row formats into the user experience. So as you can see, in this particular user experience, for the generic row, we've divided each row into a table, and the table itself has 3 rows, the first of which is divided into 4 columns, the second into 2, and the third is full width. You can see that here in the underlying code, where we have for each generic row a full width table. The full width table is divided into rows, and here we are dividing up the left, 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 right, and left, and here we have the right, right, and here we have the right, left, right, right, and right, and finally we have a row where we just have the full. Each of the fields is being passed a row definition. This tells us what row we're trying to render, a field name, so this tells us which field within that row we're attempting to render, and a copy of the myInstance parameter, which tells us what data we're trying to render and provides also the form definition that we're going to use to render that field. Let's have a look at the detail of the field user component. So the field user component is really acting as a dispatcher. All it's trying to do is determine whether or not there is a field to display. If there is a field to display, it's then going to break down and display the field information. So let's have a look at what that field information looks like. So each field is broken into 5 main sections. At the top of the field there is a label, potentially a description, and then either any custom fields that you decide to create, and we will have a separate video that shows you how to add custom fields into the user experience, or alternatively you can use one of the Great Ideas default field types, and then finally there's an option to put description text at the bottom of the field as well. Let's have a quick look at this in the user experience. So here is an example where we have a prefix field. We can see that the label is prefix. The little red asterisk is being added to show that this is a mandatory field. We have some descriptive text above the field. We then have the actual rendering of the field itself. And in this case, there's no descriptive text below the field. And this is common across all of the fields, across all of the rows, across all of the tabs, and all of the forms. So let's see how this works in code. So here you can see we've been given a row definition. What's happening here is we're scanning the row definition for all of the fields within that row that the user can see. So here we're checking the name of the field that was defined in the user experience against the name of the currently selected field from the row definition. And if there is a match, we're going to render this particular field. So first of all, we're taking the field user experience of the matching field. We're taking a copy of the field definition element. And here we figured out that there is a label and what the label is. So assuming that we have a field user experience to display, the first thing we're going to do is display the label. Once the label has been displayed, we're going to determine whether or not this is a required field, and if it is, then we're going to add the required field marker to the label. This is where we check whether or not there is any description above the field and render that description. And here is the same check to see whether there is any descriptive text that should occur below the field. So this switch statement is where we render the actual content of the field itself. By default, we will pass the request into the GI field processing, and the GI field processing will attempt to render the field using one of the GI field user experience components. All of the GI field user experience components are defined in the fields folder. The GI field component is essentially just the dispatcher that's going to call one of the detailed GI field renderers to actually display a particular field. For example, if we're trying to display a string, then we determine whether or not it's a masked string or whether it's a simple text box. And we can also determine whether the field needs validation and whether the field requires a tooltip. So all of the GI components work the same basic way, and essentially you can go in and edit any of the user experience as you wish. There will be a separate video to show you how to create completely new custom controls. If you decide to add your own custom field types, you can add them into the switch statement here, and alternatively, you can override the GI field definitions. So this video has given you a quick introduction into the overall layout and structure of a generic page within the TrellisSpark framework. As you can see, you have flexibility to edit any of the user experience that you're seeing on this page here. The TrellisSpark Academy also contains a set of textual descriptions that provide more information about the overall TrellisSpark layout and how you can customize the layout components. And there are additional videos available that will show you how to add new row definitions and new user experience field components to your application. This gives you total control over the dynamic page generation component so that you can render any user experience that you choose.
To learn more about Great Ideas products and solutions, visit greatideas.com. That's great ideas with a Z.com. Thanks.